So what we are seeing over here, the same data, this was the data, can help you get your molality as well as mole fraction. So if mole fraction of something is given, can we get the molality and vice versa? Yes, we can. So let's do a question on that. Say mole fraction of a KOH solution is 0.2. Find the molality of KOH. There is a solution in water. There is the mole fraction of KOH in water. That's the only other species. That's water. Nothing else. So find this. I hope you got it. You can do it in several ways. I would say represent the mole fraction in a very conducive way so that you can solve it. It is 2 by 10, which is 2 moles of KOH divided by 2 moles of KOH plus 8 moles of water. So this will be the moles of water if there were 2 moles of KOH. It could have been 200, but I am just taking the ratio. With 2 moles of KOH, it is 8 moles of water, and 2 moles of KOH over here, because the total was 10. So it is, for my convenience, I have written like this. You could have written it as any other way. You could have written it as 1 by 5, and you could have written 1 upon 1 plus 4. Any which way is okay. So it is 8 moles of water. So 8 moles of water is going to weigh how much? Because for molality I need to know the weight. Or let's do 4 moles. So 4 moles of water is going to weigh how much? So weight in grams is 4 into 18 grams. Weight in kg is 4 into 18 by 1000 kg. That is what we require for molality. Weight in kgs, mass in kgs. So what is the molality? Molality of KOH, that will be number of moles of KOH. So with 4 moles of H2O, it was 1 mole of KOH. That is number of mole of KOH divided by the weight of H2O. Weight of H2O is 4 into 18 by 1000. So I'll put the 1000 on top. So that's your molality. So what we see over here is when the mole fraction is given, we could calculate the molality. Similarly, if the molality is given, can we calculate the mole fraction? Do one. Say molality of KOH was equal to 0.2. Find the mole fraction. It's solution in water. So you can do the same trick. I hope you got it. So you can do the same trick, write it in a conducive way. This means 0.2 moles in 1 kg of water. Now 1 kg of water is how many moles of water? Because if I know moles, then only I can do mole fraction. So 1 kg of water is 1000 grams divided by 18 grams. So many, so would come something above 55. So it is 1000 by 18 moles of water. So we see 0.2 moles of KOH is dissolved in 1000 by 18 moles of water. So the mole fraction will be 0.2, that is the moles of KOH, divided by the total moles, which is including KOH. KOH plus water, which is 1000 by 18. 0.2 could be neglected in front of this if it is a dilute solution. If it is this dilute, so it would roughly give you 3.6 divided by 1000. So 3.6 into 10 power minus 3. But I'll leave the answer in this format so that you know the concept. So that's about mole fraction, and then molality. A simple question on mole fraction, simple question on molality, and then if mole fraction is given, how to calculate molality, and if molality is given, how to calculate mole fraction. So basically, if we have mole fraction or molality, we have roughly the same data. I can't say that a certain mixture had this mole fraction and that molality. A mole fraction given automatically translates into how much of molality has to be there.